Let us understand how do we find a polynomial equation when the roots of the equation are given. In this case, two of the roots are complex roots. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Our students are right there on the top, getting admission to the best universities and even with scholarship. In this video, let's understand the strategy of finding the equation when roots are given to us. So, roots of polynomial function are at x equals to minus 3 by 4 and x equals to plus 2 plus minus 3i. I, as you know, is square root of minus 1. So, I is the imaginary number which is square root of minus 1. Now, once you get a family of curve with these roots, with the given point in part 2, which is question 2, we are given a point minus 143 on this curve. You need to find the equation of the polynomial. So let's begin with the given roots. So the function f of x, for example, can be written as a times, because as you can see, it is family of curves. The roots are x equals to minus 3 by 4. So that means 4x plus 3, right? Factor will be 4x plus 3. You can see that if x is equals to minus 3 by 4, we'll get a 0 because of this factor. Perfect. Now the other root is 2 plus 3i, and then we have 2 minus 3i. So we can write the roots as x minus 2 plus 3i, and third root will be x minus 2 minus 3i. So that is the third factor. So every root which you are given to us with multiplicity of 1 in this case will have those many factors. So x minus a, right? Now the idea is to simplify it. We can write 4x plus 3. Let's deal with the part having the complex number. If you open the bracket, you get x minus 2 minus 3i times x minus 2 plus 3i. Correct? How do we multiply it? Well, if you do this multiplication, there are many terms. However, you do notice that you can rewrite this as x minus 2 as one term, right? And then just x minus 2 minus 3i times x minus 2 plus 3i. And now you can apply the formula. If you have a minus b times a plus b, it is a square minus b square, right? So let's continue. You got a times 4x plus 3. At this stage, I hope all this is known to you. So we have here a square, which is x minus 2 whole square, right? Minus b square, which is 3i whole square, correct? So we have multiplied the second and third terms. We are left with a times 4x plus 3, the first term, and then the second and third terms. We can expand, simplify this. Let's do it. We get a times 4x plus 3, and expanding x minus 2 whole square, we get x square minus 2ab, which is 4x, plus 2 square, which is 4, and minus 3i square. Now, square of 3 is 9, and I square is minus 1, so we get plus 9 here. Makes sense, right? I square is negative 1, right? When I is square root of minus 1, we know I square is negative 1. So negative 1 times the negative gives you positive 3 square is 9. Perfect. So this gives you a times 4x plus 3 times x squared minus 4x plus 13, right? 4 plus 9. So that becomes the factored form, a general equation in the factored form for the given roots, right? So that helps us to answer the first part of this particular question. Perfect. Now we can do part 2. We are applying the value of minus 1 and 43. We can find the value of a, right? So let's move on further. I hope it is absolutely clear. So now we have f of minus 1, which is equal to 43, and substituting minus 1 in our equation, which was what? Let me rewrite the equation here. A times 4x plus 3 times x squared minus 4x plus 13. Substituting minus 1 here, we get a times minus 4 plus 3 times 1 plus 4 plus 13, correct? So that gives you 43 equals to a times minus 1, that is minus a now. And when you add these, you have 5 plus this as 18, right? So we have minus 43 over 18 is the value of a, correct? So we have the value of a, which is minus 43 over 18. And therefore, now we can write down the polynomial, specific polynomial, which goes to the point minus 143 as minus 43 over 18 times 4x plus 3 times x squared minus 4x plus 30. Makes sense, right? So that is what we got in the factored form, right? Now, if you look carefully, we have mentioned to write the equation in standard form that goes through this particular point. So once you have this equation, we have to now expand and simplify the factors given to us, right? So let's do it. Now let us write down the equation in the standard form. So let's copy the equation. We have for this f of x is equal to minus 43 over 18. One of the factors is 4x plus 3, and the other factor is x squared minus 4x plus 13. Let us now expand this. 4x times x squared is 4x cubed minus 16x squared. 4x times 13 is 52x. Now multiply by 3, we get 3 more terms, plus 3x squared minus 12x plus 39. Correct. Now let's combine the like terms, right? 4x cubed, 16x squared plus 3x squared gives us 13 minus 13x squared. Now the x terms, we have 52 minus 12, which is 40x, and the constant term, which is 39. Now, you can always use a calculator to multiply minus 43 by 18 with each and every term and get the equation in standard form, correct? I'll leave it here. Perfect, but you need to multiply each term with minus 43 by 18 and get your result. I hope that makes sense. So with that, we have learned how do we effectively use the complex roots, right? The formula a square minus b square is very handy. And then, given a point, how do we find a specific equation for the given roots and a point on the curve? Perfect. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.